The Object-Oriented Programming Paradigm. Introduction. Hi everyone, I hope you are all keeping well. This tutorial will introduce us to the concept of object-oriented programming or object orientation in the Python programming language. This is a very important concept in Python and is categorized in the intermediate to advanced level. This tutorial has a bit of repeated notes here and there, but it is necessary because each builds up on the next concept. This tutorial will be a bit different from the previous ones we have seen, in a sense that you will notice that I have scattered a few factual theoretical points across the slideshow. Be sure to read these points and ensure you understand to the best you can. Do not hesitate to reread the work. Understanding the meaning and logic and technique behind the explanation is, as always, important to gain a high level of insight. So, without any further ado, let's get into it together. What is object orientation? Object orientation is a programming paradigm. When object orientation is used in conjunction with a programming language, that programming language is said to have or make use of one more programming paradigm. This paradigm, when present in a programming language, is called object-oriented programming. It is often abbreviated as OOP. Object orientation is one of the most powerful paradigms that the Python programming language supports and is arguably the most important paradigm in the programming language called Python. Object-oriented programming. Let us break this term down into its respective constituents. Object refers to an entity. It is a noun. It refers to an actual object, living or non-living, animate or inanimate. It can be seen and touched. Oriented refers to the process or behavior of adapting something to fit in the current instance, situation, or circumstance. In our case, we will need to adapt that something to fit into our script programming. Programming is the process of writing computer programs or software applications. Therefore, object-oriented programming refers to the programming paradigm that allows software developers and programmers to cast and model, orient real-world objects, people, books, table, chair, etc., and their attributes, gender, number of pages, color, height, etc., as digital code in which embedded templates reside. So in simple terms, object-oriented programming allows us to cast and represent real-world objects such as a person or book as Python code. Before we move on, head to your Python IDE of choice and type and run the line of code below. Print type 13. So what we are doing is printing the type of the value 13. As you know, the type function will provide us with information about the class to which the object we pass in belongs. We will notice that output to the above line of code will show as seen on the next slide. Class int. We are outputted with class int. You may wonder, what exactly does this mean? Let us discuss in detail. Classes in Python. What is a class? A class in Python, as mentioned before, is a template for an object. At the core of object-oriented programming, we have classes. Classes allow us to model, represent, and work with real-world entities. You see, in our example of print type 13, we are printing the class to which the number 13 belongs, and we are outputted with int being the class. The int class is the template for all numerical whole number pieces of information in the Python programming language. You see, the Python developers have created several built-in data templates that other programmers and software developers can use when they are programming in the language. These built-in classes are automatically detected by Python and the IDE you are using and during the compilation phase. For example, integers, strings, booleans, lists, dictionaries, and much more are all classes in Python. They are templates to objects which may be utilized by programmers to model real world entities and problems. When a programmer makes use of these classes, the particular point in your script in which you use the class is called an instance of the class, and the instance is referred to as an object in Python. A simple example: student name is equals to Bob. Print type student name. In the above image, we understand 100% what is happening. We see that there is a variable being created with the name student name, and that variable is being assigned the value Bob, which as we know is of string data type. We thereafter make use of the print and type functions to print the associated information regarding student name to the screen. We obtain output as follows: class string. So now we will analyze what has happened in our program, but from the perspective of the object-oriented programming paradigm. You see, when we wrote this line of code, student name is equals to Bob, what we didn't discuss in the beginning is how object-oriented programming is present in this simple line of code. Firstly, Python developers have created these built-in data types in Python. These are just templates that may be used in a programming language. Second, programmers are able to use these templates in several ways to code a script that will accomplish a task. For example, we are using the string class to model the name of an actual student. Third, this line of code is our instance of the built-in string class in Python. Bob is the object because Bob is the instance of the string class. A class is the template to create certain objects. Using our example, we are using a template that has been created by the Python developers. The string class in Python is identified by the use of quotation marks in the script. An instance is the particular or specific moment in which an object belonging to the class was created. In our case, we created the instance Bob because we have surrounded this value with quotations. An object is an instance of the class. An object arises at the point the class is instantiated. I do hope these terminologies make sense to you. Looking back at our example, we see that we are outputted with class string. This is because the type function will return us with the class to which an object belongs. In our case, the object is being stored in a variable called student name. Therefore, we print the type of the contents of the student name variable and we are provided with class string. You may be tempted to say that the object or instance of the string class in the program is the student name variable. However, it is important to note that our variables are not objects. They are merely temporary containers that store our objects for the duration of script runtime. They reference the actual objects that get stored in our computer RAM. The actual object is in the raw value itself, in our case, Bob. So, using the concept of object-oriented programming, we are able to store real-world information of just about any object. For example, let us now learn how to model a book in Python. Book name is equals to Charlie and the Chocolate Factory. Book author is equals to Roald Dahl. Book pages is equal to 513. Notice how in the above image we are using the concept of object-oriented programming to model and store information about an object, a book. The main issue is that there is no permanency in this technique that we are using. We are merely creating variables and assigning them information pertaining to a physical book in the real world. We can confirm this by viewing the class to which each of these pieces of information belongs. Print type book name, print type book author, print type book pages. Output will show as follows: class string, class int. We see that the object we are modeling belongs to a mixture of classes. This is again because there is no permanency in the template. Logically speaking, those separate pieces of information we are storing, name, author, pages, are attributes or characteristics of the actual object that we are trying to model. So to essentially create a book, we need a book data type. We need a book class. So in times when we require a new data type template, we obtain one by creating a new class in Python. Before we move on with the tutorial, let's take a moment to rationally understand our journey with Python in an effort to understand the concept of object-oriented programming, classes, attributes, and methods on a higher level. Why do we need classes? On our journey with Python, we have seen and continue to use several different data types in our programming scripts, examples being integers, strings, floating point values, boolean values, and much more. Each time we use these data types, they allow us to hold a single item of data such as the string Bob or the integer 13 or the boolean true. The question that we programmers are faced with is how will we ever be able to represent an actual book, person, or other entity in our program? The answer to this is we will need to use a class. Logically speaking, every object will have attributes that may be used to describe it or distinguish it from another. And based on our Python experience, we would be able to store and represent the attributes of any type of complex object using a combination of these built-in data types. The attributes of an object will make use of existing data types such as integers, strings, boolean values, floating point values, or any other existing class. Another word for attribute is field. Example, if we were to model a new class called book, a few of the attributes we could give it are a field or attribute for the name of the book, a field or attribute for the author of the book, a field or attribute for the number of pages that make up the book. We require classes to model objects that exist in the real world in our Python scripts. When classes are present in our script, it is the equivalent of saying we have a physical book in our program, we have a physical person in our program, and so on. Built-in data types, classes, do not cater for every object in the world. Therefore, the Python developers have provided programmers with a technique to model any required object in the programming language. This is done using a class. Built-in data types are used to model attributes that our class has in the real world. The difference between classes and objects. In Python, classes, number one, behave like a template that programmers can use to create instances or objects of that class. Number two, have common methods or behaviors for all objects that belong to that class. Number three, have attributes or fields to hold data related to the created object. Number four, have methods that may be accessed or called. In Python, objects, number one, are created from a class. Number two, hold their own values for instance variables. Number three, may have instance methods or attributes. Number four, may have copies created and stored in system memory. A simple diagram to depict the difference between classes and objects in Python is shown on the next slide. Class car. Attributes, behaviors. Car1, car2, car3, car4, car5, car6. The previous diagram does a good job of explaining the concept of object-oriented programming in detail to us. Classes allow us to model and work with real-world objects in Python. Python creators have catered for data types such as integers, strings, booleans, and a few others. But if we as programmers would like to create and model an object such as a car, what would we do? A car, realistically speaking and logically speaking, cannot be represented as integers or a string of characters. We need an approach that can help us to permanently integrate a new data type into our program, a car data type, class. This is why we are able to create a new class in Python to represent a real world object that we would like to model. The class of this data type would be car. A car is an object. It has attributes that tell us more about the physical appearance of the car, such as color, weight, and number of safety airbags. And it has behaviors that tell us more about what the car is doing or what the car can do. For example, drive, reverse, engage handbrake, and so on. Now, objects and instances arise from a class. In our diagram, we have a car class and we have six different objects or instances related to this car class. The six objects we have created are car1, car2, car3, car4, and car5, and car6. It is interesting to know that all Python classes work in the same way or using the same logic. Every object that we create in our program is a part of a class, and this class ultimately forms a part of object-oriented programming. Each car object or instance that is created from the car class will belong to the same car class, but each object or instance will have the same properties but different values for those properties. Each car object may differ in weight or color and so on. And since we are providing values for and information to be stored in the attribute variables, we are allowed to access these pieces of information, because what point would there be in modeling a class storing information to the attribute variables but not being able to access this information at a later stage? And when we access this information about a class, we do so using the object methods. We will see how this works shortly. That is the overall concept of object-oriented programming. Despite Python not catering for real-world objects via built-in techniques, the Python developers allow programmers to create classes, object templates, to build and model real-world objects in their Python scripts. For our understanding purposes, it is logical to think of a class as just another data type in Python. I will explain and show you an example of this as we move along.